which is like the loss function drops sharply and then it stays stable all the way, and then throughout all the epochs, right? And uh, after that, I'm using this to predict on the test data. And here we have a plot between the actual versus the predictions on the test data set. And you can see that it is following a pretty similar trend, and the spikes are also pretty similar, although not as uh, I mean, the values are not comparable with the actuals, but still the trend is similar, and it is going in a similar fashion at all these points. So the more after this, I mean, we have evaluated that the model is generating good output, and we can train it for forecasting model. So we will use both the training as well as test data set together to train the forecast model, and we are still using the 100 epochs over here. So once the forecast model was trained, we generated a forecast ranging between 7/1 2021 to 9/30 2021, and then we got the actuals also from the second file that we discussed about in the first um, part. So here we plot both the actuals versus the forecast. And here what we see is that it is not as the predicted values, and but rather it is showing a trend. So the trend is pretty, I mean, it is kind of similar because it is increasing as the time goes by, but I mean, the actual values are pretty different from what we have on this graph. So, I mean, this model is forecasting the trend in a good way, but the actual values are not as accurate as theirs as we were like expecting. So we were asked to redesign the neural network model to try to improve the performance. So again, we will use the same two files, and also I have the Python notebook and the PDF attached in the project files. And in the redesign, what I'm trying to do is like I'm trying to improve it. So what I did was I was trying to reduce the dropout rate from 20% to 10%, and I also reduced the number of neurons from 50 to 30, and also one thing I changed was like I increased the number of epochs from 100 to 120. So rest of the design is pretty similar. It's still like 6 layers, 3 LSTM layer, 2 dropout layer, and 1 dense layer. And then we have the same data sets, and we are using a similar, splitting method. But only thing is like we are keeping 90% for training and 10% for record test data, which we were doing earlier also. And then we are normalizing the data between 0 and 1, both the training data set and the test data set. And we created the time series generator using 60 historical data points. 30 batch size is still 32 samples per batch, and we again build a model as described above. It still has the 6 layers. Only thing is like we are using 30 LSTM cells, and we are using 10% dropout, and we are using 120 epochs to train the model. So after that, basically, I'm still using the Adam optimizer and mean squared error as the loss function. And after that, I basically train the model. And here I'm basically plotting the loss function. So here we can see like initially the loss increased, but after that it sharply decreased, and then it remained stable at a level for all the epochs. So once after that, basically we will evaluate the model on test data set. So here is the plot for the actual versus the predicted values. So here we see that it is also again it is not predicting the values accurately, but it is following the trend pretty good. So we'll continue with this, and then we'll train the forecasting model for the listing for this problem. So we'll use the training plus test data set to build the forecasting model, and we'll use 120 epochs for this one, and it will be used to predict the maximum air temperature between July 1st and September 30th. And since the data is normalized, we'll inverse transform it back to true values, and then we'll compare it with the actuals that we get in the second data set, and then we plot it over here. So here we see that again, I mean, we are not predicting the values accurately. It is a straight line over here. Otherwise, and the actuals are um, like modulating between like 85 and 100, but this is pretty standard. It is going like between 92 and 97, I guess, 96. So that's with that model. So I think we the trend is, I mean, it is still showing the trend, which is the temperatures are increasing in these 90 days, but I see that it is also not predicting well. So the next part is to compare the network performance. So we're going to compare the two models that we created in this part 4 and part 5. And we are trying to predict the maximum air temperature in the Dallas FAA airport radar station. Below is the comparison. So we have model 1 versus model 2. So the model 1 is the part 4, which was the first model that I created, and model 2 is the part 2. We see that the loss function is pretty similar. We see the trends are pretty similar, although it is um, fluctuating more, which is the actual, which is closer to the actuals. But here we are fluctuating less, but still it is similar. And then we evaluate the actual versus forecast in the forecast model. We can see that here we had earlier it was low, but then it increased sharply and then stayed over there. But here it is increasing steadily. So there is a little bit difference in the trend, but both the trends are still showing that the temperatures are increasing over the number of days. So I also tried to see how the data set looked like. So I described the data sets, the final data sets. So here is the actual values, and here is the forecast for the model 1, and here is the actual value, and here is the forecast for model 2. So what I see is like for the, if you see this mean section, the model 2 mean is closer to the actuals, while model 1 is like way above the actuals. So both the models are pretty close to each other. The loss function for it is very similar. Evaluating test data, I mean, we already discussed this. All these are pretty similar. So by looking at all these comparisons, I feel like that we have only seen a slight improvement in model 2, but that is not enough to say that it is better than model 1. I think I would like to change the network by removing dropout layers and see if it works. And I think that's all for my project report that I want to discuss. So thank you very much, and have a great day.